Hello everybody. In this section we're going to focus on electrolysis, and we're going to look at 4 different scenarios that you need to know in order for you to do incredibly well on any electrolysis question. So to start off with, what does electrolysis mean? If you break down the word into electro and lysis, lysis means to split. So electrolysis is the splitting or breaking down of a substance, which we call the electrolyte, by using electricity. Now it's important to remember that that substance needs to either be molten or dissolved in water. So for example, from the rock bauxite, we get the compound aluminium oxide. If we use a lot of energy, we can melt the aluminium oxide and therefore split it by using electrolysis. And that's why electrolysis is very, very expensive. On the other hand, we can take a substance and if it dissolves in water, we can conduct electricity through it. So sodium chloride in solution will be able to conduct electricity. To show that it's in solution, I put the AQ sign next to it to remind me. So now let's go and look at 4 scenarios that you could come across. In the first example, we look at an electrolyte that is melted, such as aluminium oxide. We set up our electrolysis experiment by connecting 2 electrodes to the positive and negative terminals. To help us remember what goes what, the positive is the anode, the negative is the cathode. So don't panic, remember panic. Positive is the anode, negative is the cathode. So there we have positive and negative. Now if you mixed up with your symbols, positive, if I take those 2 lines and join it together, the long line is the positive one. Now in this example, when we've melted aluminium oxide, we've got aluminium ions and we've got oxygen ions in our beaker. The aluminium ions are positive, so they are going to be attracted to our negative cathode. Positive ions are called cations. I remember the T in cations looks like a positive sign. So positive ions can be called cations, and that's why the electrode the cations go to is called the cathode. The negative oxygen ions are going to be attracted to the positive electrode. Negative ions are called anions, so the positive electrode is going to get its name from that. It's going to be called the anode. So it's all about opposites attracting. Now, if you are in higher tier, you will need to know how to write ionic equations for the reactions that happen at the cathode and the anode. Ionic equations are ones where you show the electrons in the equation. So the positive aluminium ions are going to gain electrons that are flowing through the circuit to form aluminium atoms. In this case, where we gain electrons, we call it reduction, and we use oil rig, where reduction is the gain of electrons. Another useful memory hook is the red cat. Reduction happens at the cathode. On the other hand, at the anode, the negative oxygen ions are going to lose the electrons it had gained to form oxygen. And because oxygen is diatomic, it can never be written as O on its own. So I've just got to manipulate the equation, and on top of that, scientists don't like writing negatives. So I change the equation around to get 2 oxygen ions form oxygen gas and 2 electrons. And using oil rig, I'm reminded that this is called oxidation because electrons are lost. Oxidation is the loss of electrons. Now, I love Highland cows. And using anox, I'm reminded that at the anode we get oxidation, just like at the cathode we get reduction. Now let's look at our second example. If the electrolyte is a solution, for example, sodium chloride, something slightly different needs to happen. So with sodium chloride, the sodium chloride is dissociated into sodium ions and chlorine ions, and water dissociates into hydrogen ions and hydroxide ions, OH-. Now we've got an interesting situation because you can see there are 2 positive ions and 2 negative ions. So using what we learned last time, we know that the negative ions are going to be attracted to the positive electrode and the positive ions are going to be attracted to the negative electrode. And this time we've also got the hydrogen and the hydroxide ions. And remember, in our electrolyte, we're going to have millions of these ions. Now, we've got an interesting situation because we've got 2 different ions going to each electrode. But what actually forms? There's a bit of competition that goes on, and this is how we determine the winner. At the anode, if there's no halide present, oxygen forms. If there is a halide there, then the halide would form. So a halide is a group 7 element. And in this example, we've got chlorine, so chlorine is going to form. The rule at the cathode that we need to know off by heart is that if the metal is more reactive than hydrogen in the reactivity series, then hydrogen forms. So in this example, sodium, we know in group 1, is very reactive. So hydrogen is going to form and the sodium is going to remain behind in the solution. If the metal is less reactive than hydrogen, then the metal forms. So that's if we've got copper, silver, or gold. So the equation for what forms at the cathode, the hydrogen ions gain electrons to form hydrogen gas. Again, diatomic, so don't get caught out. And at the anode, the chloride ions are going to lose electrons to form chlorine gas, which is diatomic, so we've got to manipulate the equation, so it's Cl2, and we get oxidation taking place there. So those rules in yellow are really important for you to learn. Let's look at our third scenario. In this scenario, we're going to use copper sulfate solution, which is a beautiful blue color, and the exam board likes you to know what the colors are. In this situation, rather than using graphite carbon electrodes, we're going to use copper electrodes. Now, if I'm trying to use recycled copper to form lovely new copper, I'm going to use this method. And what I do is I put the impure copper at the anode. And what I want to do is I want to take that lovely copper from that anode and transfer it to the cathode. So pure copper goes to the cathode. Now what happens is the copper at the anode is going to break down into copper ions, and those copper ions are then going to be attracted to the negative cathode. So this is the reaction we get at the anode. The copper loses electrons and forms copper ions, and those copper ions can then gain electrons at the cathode to form copper. In this situation, when we do the core practical, we learn that the mass lost at the anode equals the mass gained at the cathode, as long as no bits of copper falls into the solution. Now, in our final example, we also use copper sulfate solution, but this time, rather than using carbon electrodes, we use our favorite inert carbon electrodes rather than copper. So in this situation, with our copper sulfate solution, the copper sulfate breaks into copper ions and sulfate ions, and the water, as we know, breaks down into hydrogen ions and hydroxide ions. So we have this scenario where we've got the copper ions going to the cathode and the hydrogen ions going to the cathode. The sulfate ions are going to be attracted to the anode, and the hydroxide ions are going to be attracted to the anode. Now, where we have two different ions forming at the electrodes, we've got to go back to our rules. And the rule says at the anode, if no halide is present, oxygen gas forms. Now, if we look at those ions, none of them are from the group 7 elements, so oxygen is going to form at the anode. And at the cathode, it says if the metal is less reactive than hydrogen, then the metal forms. And copper, we know, is less reactive than hydrogen in the reactivity series. So, at the cathode, you're going to get this reaction. Copper is going to pick up 2 electrons to form copper atoms. And at the anode, we get this rather complicated equation, which I would just learn off by heart. Now, because copper is forming at the cathode, if you remember from class, you get that beautiful reddish brown color forming at the cathode, showing you that copper is indeed formed over there. So make sure you can recall those 4 different examples and the couple of rules to help you along the way. Good luck.